So if you remember, and you do not have to remember the difference quotient in this class, my calculus class has to. The definition of the difference quotient, and this is f of x plus h minus f of x divided by h. What does it mean? And this is valid for any f, function f of x. It means it's the rate of change of f of x at any point. There are certain restrictions and certain conditions, but I'm not going to put them here because they're not part of this course. I'm going to put in parentheses under certain conditions. Under certain conditions. So we are asked to determine the difference quotient, which is the rate of change of the function at any point, for different functions. For any category of functions, for any function, two things must happen. When I determine that ratio and simplify it, two things have to happen. So here's the note. 1 and 2. Conditions that must, I shouldn't say conditions, but two things have to happen every time I determine and simplify the difference quotient for any function. Number 1, all terms without h, the little h, must go away. Which I should write, must simplify. Simplify. Number 2, little h from the denominator must go away as well. Only the one from the denominator, this one. So h must go away from the denominator. So these are the two conditions. If they are not fulfilled, I made some errors. So now let's choose a function. Let's choose a quadratic function. Give me any quadratic function you want to determine the difference quotient for. Say it again.
2x squared minus x minus 3.
I love it when my students are way ahead of me. You could teach this if you want, and I can sit down and relax. Yes? No? Okay, fine. Good. So I'm given the function. I will copy here the difference quotient. So this is f of x plus h minus f of x divided by h. And this is the given function. This is my f. And I have to determine this and simplify it for that function. So I'm asking myself what I have and what I don't. And it's very clear that this is, I cannot do anything to f of x. I will have to copy this in here, replace it by what it equals to. It's very clear that there is nothing I can do to this little h. And it's also clear that the one quantity I don't have is this one. I did not determine it. I did not look at it. So now is the time to look at it. So can anyone tell us what does this equal to? The function is given to us. 2 blah squared minus blah minus 3. Can anyone dictate what to write next?
2
Yes?
parentheses x blah squared minus x plus 8.
It must be in parentheses.
Parentheses.
Yes. And minus 3. This is awesome. This is exactly what it means because we understood the pattern of the function. The function says 2, the variable squared, times the variable squared minus the variable minus 1. Perfect. And that's what we did. Is everyone in agreement with this? Any questions? Any questions? Okay. So now I have to simplify this as much as I can. So can anyone give us the next step? My Walmart markers are drying out.
Distribute to 2.
I can never distribute. Can anyone say why I can never distribute? Because I got the power. By the order of operations, I have to do what first?
Square.
Awesome. So then I'm ready.
2 times the quantity.
Good.
X squared
Yes.
plus hx. 2x.
Thank you.
Plus h squared.
Very good. Awesome. This is clear. Negative x, negative h minus 3. Now I'm allowed to distribute. So this is 2x squared plus 4xh plus 2h squared minus x minus h minus 3. So what does this mean? All these terms, 6 terms, will replace this expression, this name actually. It's not even an expression yet. So I will continue replacing this piece by all this and putting everything together now, because now I have all 3 pieces. So the difference quotient equals, I will copy 2x squared plus 4xh plus 2h squared minus x minus h minus 3. I got to this step. Can anyone distribute for us the negative 1 to these 3 terms?
Minus 2x squared plus x plus 3.
I couldn't have said it better. Divided by h. Thank you very much. Okay, so now let's go back to what we just said, the note. Any questions? Stop me if you have any questions, please. Any questions? So now remember the note. The note said what? That from the top, all terms without
H.
must simplify. Okay, so let's try. Look at the terms without h and tell me if they simplify. 2x squared.
Why did you minus 2x squared?
You have a minus, it's a difference. So you have to have minus quality 2x squared minus x minus 3.
Oh, okay.
Very good. Perfect question. So then 2x squared with negative 2x squared, would you agree? Would you agree negative x with positive x? Would you agree negative 3 with positive 3? How many terms are left over?
4xh.
1 term, second, and third. What do they have in common? They must have something in common because the second thing has to happen. They must have h in common. Please look for a moment. And only now I'm allowed to simplify h from the denominator as the second step that has to happen. So then what is left at the top, please?
4x plus 2h minus 1.
And this is the final answer, 4x plus 2h minus 1. This is the difference quotient. So let's choose another function. Those functions are on your book on page 252, 71 through 92. 71 through 92. Yes.
Where did you get the minus 1?
H times 4x, 4xh. H times 2x, 2x squared. H times negative 1, negative h. That's why I asked you first, how many terms? So then there is no mistake when we write them in. So don't rush. Say, how many terms do I have? 3. So then I have to have 3 in parentheses as well. Good. And I spoke too soon. There is one other topic that we have to cover from this section, and then we can move on. Yes, would you like to choose another? Any function? Always keep in mind, for any difference quotient, for any function, 2 things must happen. And one more time. All terms without h at the top must go away. It's a bonus if terms with h go away, but that's, you know, not usual, not common. I shouldn't say not common, but it's not, we don't care. If they do, it's a bonus. If some of the terms with h go away, it's even better. But all terms without h must go away, and eventually this h from the bottom has to disappear. For all difference quotients, for all functions. Okay, we like to choose another or we move on? Yes. Any preference? Another quadratic or something else? It can be a rational, it can be a radical. Quadratic, rational, radical.
Rational.
Okay, perfect. So let's take a look at a rational function. Here it is. So f of x, so in problem 90, f of x equals 1 divided by 2x. Okay, so the difference quotient, I copy. This will be given to you on a test or final exam. You don't have to memorize it. I don't think it's difficult, but it will be given to you. I analyze the three pieces, and I realize that I have f of x. Little h is not in the way, and the only piece I don't have is which one? Which is the only piece I do not have? Let's take a look at the previous example and see what we calculated. What did we calculate in this previous example? We calculate f of x plus h. Good. Can anyone give us f of x plus h for this function?
1/2 quality x plus h.
Very good. Awesome. I copy f of x, and I copy h. No one can change f of x. No one can do anything to h. So these two are fixed. The only one that I have to determine is this one. So we did. Very good. How do we proceed? What is my next step? Obviously not in the denominator. There's nothing I can do to this little thing. So I have to do something here, which is what? What am I? A sort of, that would be for proportions, but I know what you mean. So first of all, what am I doing? What is this operation? How do you call it? A difference of two fractions. A difference of two fractions. Clear? Okay, how do I find a difference of two fractions? What do I have to find first? Say it again. Of course. So let's find the least common denominator. This is not a polynomial. I have to find the least common denominator. So what is it? How many different factors we see here? I see three. I see 2. I see x, and I see
X plus h.
x plus h. All three have to be in the least common denominator. 2x, x plus h. Any questions, ladies? Questions, ladies, ladies. Any questions? Please talk to me if you have questions. Okay, for now, you may have. Good. So what do we multiply the top of the first fraction by? Indeed. What do we multiply the top of the second fraction by? Very good. So please give me the top. Very good. Do we all agree with x minus h? This is what we did in rational equations. Go ahead.
Isn't it x plus h?
You mean here?
Yeah.
Okay. -1
Oh.
distributed to x, -1 distributed to h. No problem. I'd rather go back and see, maybe there is a mistake. What did we say that has to happen at the top? Terms,
Without h, which is a
do they go away?
yes.
Good. These two are out. The numerator is a fraction. Look at what I do now. The denominator is also a fraction. How do I divide two fractions?
The second one.
Copy the top and flip the denominator. And the second thing that must happen is, otherwise we have an error,
H. Oh, wait.
this one. Divide by h. And what is the difference quotient? Simplified completely. What does it equal to?
1 over
But we have the minus in front. Yes, indeed, 1 over.
2x squared plus.
Yes, it's a very good point you are making. Very good point. Thank you for saying that. Never distribute the factors in the denominator. We never distribute. It's not an error. It's not a mistake. It's a waste of time. And we need them factored. So never distribute the factors in the denominator. The denominator has to be a bunch of factors and not terms. Very good. If you hadn't said that, you would have not helped me mention this. So please, always speak up, speak your mind, even if, you know, it's something that I need to correct. Especially if there is something that I need to correct. You should speak up. Okay? So we can solve all problems here. Okay. I'm sorry?
Oh, never.
That's okay. So do we have other questions? Are we okay with the difference quotient? Do we need other examples or can we move on? Yes. What type of function?
The quadratic.
The quadratic. Can anyone give us a quadratic from your book or from your memory? 1, 2, 3. Negative 3x squared plus 7x plus 10. So we made up a quadratic function and we want to find and simplify the difference quotient. So the difference quotient is by definition f of x plus h minus f of x divided by h. Which piece I don't have yet?
X plus H.
Yes, this is fixed. There's nothing I can do to it. This is fixed. There is nothing I can do to it. This is the only one I'm missing. So now let's look at the function. See what the function is telling us to do with x plus h. And once we know that, just put it in. I'm ready when you are. Yes?
2.
2 is nice, but we have negative 3.
Oh, otherwise it's
No problem. No problem. I do that a lot. So negative 3 what?
X plus H.
How, where, what do I write?
Parentheses.
Awesome. Very good. Then plus 7
Quality X plus H.
x plus h and plus 10. Are we comfortable with this step? Yes, everyone? Yes? Is that clear? This is like evaluating for 0. How do I evaluate for 0? When x is 0, 0, 0. How do I evaluate for 5? 5 squared, 5. How do I evaluate for x plus h? X plus h squared, x plus h. Everyone okay? Good. So now I have to simplify this as much as possible. What do I do first? Yes, so I have to copy negative 3, and now please square x plus h. Remember, first day of classes, we have an agreement.
X squared is 2H plus H squared.
Very good, thank you very much. 7x plus 7h plus 10. And the simplified form, now I have to remove parentheses. All I have to do is distribute negative 3. Negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h plus 10. All this will replace this because that's what it equals to. Is that clear? Everyone? Yes? Okay, so I go back to the difference quotient. I don't want to write it one more time. I'm lazy for a second. So I'm just going to copy. So from here, I jump here. I copy all this to replace this piece. So negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h plus 10. I reached this level, this step right here. Remember, this has to be distributed to everything in the function.
Plus 3x squared minus 7x minus 7.
Everyone agrees with positive 3x squared minus 7x minus 10?
Is that goes to negative?
Negative 1 distributed to negative 3x. Negative 1 distributed to 7x. Negative 1 distributed to 10. Good. Now what has to happen before we even look? All terms without must go away. If more terms go away, it's even better. But definitely all terms without h must go away. Do they go away? So I see the negative 3x squared with the positive 3x squared. I see the negative 7x with a positive 7x. And I see the positive 10 with a negative 10. Are we in agreement so far? What is the second thing that must happen
All H's was go.
The one in the denominator, only the one in the denominator. Okay, I have to count my terms so I don't have an error. How many terms are left? 3 terms. What do they have in common? So please tell me give me 3 terms. Once you say 3 terms, you have to give me 3 terms in parentheses.
Are we allowed to take the negative out of it?
You can if you want to.
Does it make it difficult?
No, it doesn't make a difficult. It doesn't make any difference. So-
Negative 6x
Yes.
3h plus 7.
Everyone agrees with negative 3x minus 3h and plus 7 after we simplify the h. And this is how we deal with the difference quotient. It represents the rate of change of a function at any point. Under certain conditions, of course.
How'd you get rid of the h?
I simplified this h by h and I got 1 and this
H in the negative 6xh when you brought it down, and then how'd you get rid of the h in the 7?
here.
Yes.
H times negative 6x is negative 6h. H times negative 3h is negative 3h squared. And h times 7 is 7h. So we pulled out the h because we needed to simplify h by h. So then the final simplified form is exactly what I have in parentheses. Is that better? Okay, other questions? Oh.
Pulling out the negative is useless. Isn't it?
You can. It doesn't. There is no problem. So you will write this, which is fine, but there is no need. Both are acceptable. Okay, last topic here is piecewise defined functions. Piecewise defined functions. Okay, let's look at an example. The question is, how do I graph a piecewise defined function? So in your text on page 252, problems 59 through 70, page 252. All these functions represent piecewise defined functions. I'm going to copy one, like 69. I have f of x 0 if x is less than negative 4, negative x if x is between negative 3 and 0, and x squared minus, yeah, I'm copying from 2 problems. Is that it? That's what I'm doing. Keep an eye on what I'm doing, because I'm notorious for doing that. Okay, so 0, x less than negative 4, that's correct. And negative x, yes, negative 4, between negative 4 and 0. I think I mentioned that to you in one of my classes last semester. I had assigned someone to keep an eye on what I'm copying. And then in the middle of the semester, he said, I give up. Can anyone take over? That was funny. He was joking about it. So this is a piecewise defined function. Why? Because it's defined using 3 functions. In other words, we say it has 3 pieces. Okay. Here's the first piece. For x values between negative infinity and negative 4, a certain graph. Between negative 4 and 0, a different graph. Between 0 and infinity, a different graph. And all these 3 together make the function f of x. Can we think of a function in real life that is piecewise defined? In other words, for this x, a certain function. For this x, another function. For this x, another function. I don't know what the tax code is right now. I don't know how it changed. If it changed, I don't know anything about it. But in the past, I'm making up numbers now, for someone who would have an income between, let's say, 0 and 40,000, I'm making up numbers. Between 0 and 40,000, they would pay 10% in taxes. Between 40,000 and 80,000, they would pay 20% in taxes. Between 80,000 and blah, 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 25% in taxes. That's a piecewise defined function. For certain x values, a certain calculation, certain procedure, like 0 or negative x or x squared. For another set of x values, a different way of calculating the taxes. For another set of x values, a different way of determining taxes. That's a piecewise defined function. Here's another one. I know we are now on all unlimited plans on our cell phones, but in the past, well, you probably don't remember, I do remember, when we had, for the first 1,000 minutes, we were paying, I'm making up numbers again, $20. For the next 1,000 minutes, we would pay a total of $25 per month. For the next blah, 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 and so on and so forth. That's another piecewise defined function. Yes?
So if x equals a certain range of numbers, it uses a certain
Particular
equation.
and no other. Yes. Exactly. Exactly. Because for people who, let's say, from 0 to 40,000, they cannot pay 30%. They pay 10% in taxes. And people who have $100,000 in income, they will not pay 10%.
It's using like a code kind of way to.
Exactly. That's pretty much it. Okay. When I'm asked to graph a function, what is my first thought? Always. The domain, right? I can't start the chart, the table of values before identifying the domain. Awesome. Very good. So I go back to the first piece. I look at this, and I change it into interval notation. And you can say why. Bear with me till the end of the graph, and you'll understand why. I'll explain why. So x less than -4. In interval notation, what would you say?
Negative infinity.
Perfect. Perfect. These two mean the same thing. Now for this one. The interval notation for this territory.
Bracket,
-1.
Comma.
and it's parentheses.
Very good. And the last one for this one. With a bracket to infinity. Now I need to establish the domain. So let's take a look. I have everything to the left-hand side of -4. I have -4. It's here. I have everything between -4 and 0. Not 0. But I have 0 here. And I have everything between 0 and infinity. Can anyone establish the domain for this function?
Negative infinity to positive infinity.
Awesome. Thank you very much. That's why I call you my best. Don't tell anyone, don't give them the link to my video. Okay, so I'll write negative infinity to infinity. Perfect. Now let's look back at what we see here and say, okay, there are two x values that have to be in the chart for sure. And why? What two x values must be in the chart?
-4 and 0.
Why?
Is there a established policy?
Why? The function changes from a particular piece to another piece. So it must be what we call the threshold, right? I go from one piece to the other. So that point must be important. Indeed, 0 and -4 or -4 and 0 in the correct order. Very good. Other x values will be chosen in a minute, but those two must be in the chart, in the table. Good. Here's what I'm going to do next, and I know you're going to ask why. You'll see why in a minute. At -4, I have a parenthesis facing this way, and I have a bracket facing this way. I will use these two symbols and write them exactly under -4. Here's how. Don't ask why just yet. Please bear with me. I will explain. And these two symbols are touching. So left parenthesis facing this way, a right bracket facing that way, under -4. Although you don't know why I'm doing this yet, can you tell me what to write under 0?
Same thing.
Same thing. A parenthesis facing left and a bracket facing right. Bear with me and you'll understand this in a blink. Okay, now I'm going to ask you, what function do I use for x values between -infinity and -4? Exactly, that's what the function is, 0. What function do I use for values between -4 and 0? That's it, that's what it says. And lastly, what function do I use? I know it's a silly question. X squared. Now you can ask yourselves, why is she putting this up here? Just to make sure, because these may not be arranged from left to right. And I don't want to make a mistake and plug in a value in a totally different function that I should. So that's why I put them on top of my chart so there is no ambiguities. There is no ambiguity here and no mistake. Okay, this is a linear function. I need at least another point. So when x is -5, how much is y? When x is -4, how much is y? When x is -4, that's very good. So here is, I couldn't pass that, and that's correct. Your colleague said, in other words, you cannot plug in -4 here, because -4 is not here. Why are you forcing -4 in this? You can't. You can put -4 only here, but not in the first one. True. But if you see, I put a parenthesis. If I don't put -4 in here, then I'm going to have to ask you to put in -4.0000000000001. It's the first number on the left-hand side of -4. You cannot stop at -5. You have to go as close as possible to -4. Instead, let's plug in -4, and it's going to be an open point. Otherwise, you have to plug in -4.0000000000000000001. And you don't want to do that. So let's plug in -4. What do I get inside here, inside the parenthesis? Plug in -4 in the function. Exactly. Notice that it's exactly inside the parenthesis. And both symbols are right under -4, not to the left or to the right of -4. Stay with me, please. Now let's plug in -4 in here. And please tell me what to write inside the bracket. Perfect. Please plug in 0 here and tell me what you get. 0 inside. And again, you should be appalled. You should say, no, I don't want to plug in 0 in here because 0 is on this side. True. But if you don't plug in 0, then you'll have to plug in -0.00000000001, and we don't want to do that. On the other side, plug in 0, please. Good. And let's also plug in 1. 1. We're ready to graph the function, and I'm sure by now you already understood what's happening with those symbols. So let's graph. Please give me the first ordered pair from left to right that I need to plot. Say it again. From left to right, the first ordered pair that I have to plot. -5, 0. 1, 2, 3, 4, 5. The next ordered pair that I have to plot, please. What type of point will this be? An empty point or an open point? Awesome. So the left-hand side, in other words, the first branch is done. Moving on. The next ordered pair, please. Very good, awesome. What type of point is this? Very good. Closed or full point, same thing. Perfect. The next ordered pair.
0, 0.
What type of point will this be? Very good. And this is a straight line. Okay, the last branch. The next ordered pair. Good, so it's okay. I'm going to fill this in. And then 1, 1. This is quadratic, so this is x squared. It's not a straight line. This is the graph of the given piecewise defined function. What is the range of this function? Exactly, from the lowest y value to the largest y value. Indeed. So the range of this function, good. Now, let's analyze this for a moment and then choose another example so we can move on. So what was the purpose of these symbols? The purpose of these symbols was to tell me that -4 parenthesis is an open point, and -4 with a bracket is a full point. It happened that these two numbers were the same, so this one left over at the open point, but this one started at the same point, so I had to fill it in, which was not the case here. So the value is 0 on the left of -4, but on the right, or I should say at -4, is 4. That's the purpose of those symbols.
And it's always gonna be like that way, they're always gonna be like that, you're not gonna ever flip them.
It depends on the symbols here. Very good question. It depends on what I'm given here. These follow what I'm given here. I cannot invent. What I see is what I have to use. So let's look at another problem. Okay, so let's look at 67. It's not as difficult as it looks. The first example is longer always because it takes me a long time to explain. X less than 1 and 2x plus 1 for x greater than or equal to 1. Well, I'm hoping that I copied from one problem. If not, you can correct me anytime. Okay, the question is we're asked again to graph this function. First question, what type of function is it? It is a piecewise defined function. So it has how many pieces? Oh, I forgot to mention one thing here. Notice one very important note is that this graph cannot be extended to the left and it cannot be extended to the right. This graph is only between -4 and 0. This graph cannot be extended to the right. This graph is only between -∞ and -4. As well as this graph cannot be extended to the left. This graph is only between 0 and infinity. If I graph something like this, what do you think about this? Is this a function? No. So please keep in mind that branches or the pieces of the piecewise defined function cannot overlap. Because if they do, then this is no longer a function. But see, if you cut this function with any vertical line, it will always be a function. So you can do something like this. It's no longer a function. So I know it's tempting. You see -x and you're attempting to graph this, but that would be wrong because it's -x only between these two x values, not beyond. Okay, that was my point. So I'm asked to graph this function. I know it's a piecewise defined function, and this one has only two pieces. So I have to start by finding the domain. So I will change these two in interval notation in case you agree to use the symbols I like to use for any piecewise defined function. Your book presents a totally different method. If you understand it, if you like it, if you prefer it, I am very happy. I completely despise it, but I will be very happy if you understand it. They separate into two different charts. Who knows where, what is happening here? But again, you may be able to understand it, and I'm fine with it. I disagree with it, but I will accept it gladly. Okay, so what is the symbol for this? The interval notation for the first piece.
Parentheses, -1.
Good.
Parentheses,
And what about this one?
bracket 1 to infinity.
Good. So now we can identify the domain, and only then I can get my table going. What is the domain of this function? We have everything between -∞ and 1. We have 1, and we have 1 to infinity. Very good. Indeed, the domain is still all real numbers. It doesn't have to be. It happens that the problems in this book are pretty much all real numbers as domain. Okay, very good. Which value I have to have in the chart, no matter what? 1. 0 is always part of the chart, no matter what, but 1 is the one that is the called, if you want, the threshold point. Good. So please give me the symbols under 1. No other number has two symbols under it. This is the only one. Parenthesis facing left and the bracket touching facing right. Very good. I know this is an overkill, but I prefer it so I don't mess up. What function do we use? Which of the two functions we use for the first territory between negative infinity and 1?
1/2 x squared.
Very good. And obviously 2x plus 1 for the other one. Good, perfect. So let's start with this first piece. I have negative 1/2 x squared. I like to put in there negative 2. See what I get. When I put in negative 2, how much is negative 2 squared? 4. 4 divided by 2. But it has a minus in front, so it's going to be negative 2. Now let's plug in 0 in this function. 0. Now let's plug in 1, although I know you are reluctant and you want to say no. Bear with me, and let's plug in 1. Inside the parenthesis, negative 1/2, right inside. On the other side, let's plug in 2, and please tell me inside the brackets, what do we get? Inside the bracket, we get 3. And let's also use 2, because it's a linear function. I need at least one more point. So I do get 5. That's all I need. From left to right, please dictate the first ordered pair that you want us to plot. Negative 2, negative 2. The next ordered pair. Very good. Next ordered pair. What type of ordered pair is that? Open, because of the parenthesis. This ordered pair must be an open point. This is quadratic, so I'm graphing a quadratic function. As you see, I cannot extend it beyond 1. Next ordered pair, please. Very good. What type of point is 1, 3? Full point, correct? Because of the bracket. Awesome. And then I have 2, 5. And this is a straight line. As you notice, this line cannot be extended to the left. The quadratic function cannot be extended to the right. They are completely separate. If you're extending any of those, the line to the left of 1 and the quadratic function to the right of 1, you are no longer graphing a function. Can anyone give us the range of this function? Remember, from the lowest y value, yes.
So, back to the chart for x and f of x, negative 2 and then negative 2, how did you get the f of x to equal negative 2?
Negative 2 squared is 4. 4 divided by 2 is 2, with minus in front, negative 2.
Oh, okay.
You're not distributing, right? Okay. So the range, please. Negative infinity to negative infinity to 0 with a bracket, union.
Oh, union. Oh.
3 raised to, I'm going to say 3, 2 with a bracket. So the range of this function, if there is a gap between 0 and 3, and that range illustrates that. Okay, any questions on piecewise defined functions? Any questions on piecewise defined functions? Okay then, 2.3 and 2.4 together. They're all about lines. So we are just going to practice. Okay, we remember that the equation of the slope is, or the definition of the slope is, if we have 2 points, given, very good, y2 minus y1 over x2 minus x1, perfect. Then y equals mx plus b is one equation of the line. You'll tell me what it is. And then y minus y1 equals the slope times x minus x1. These are the only 2 equations that we have for lines. What is the first one?
The first one's slope.
The first one is the slope y-intercept form, also called slope-intercept form, but I like to specify. But it's okay if you say it's slope-intercept form. What is the second one? Point slope form. Point, this is the point, and this is the slope. Point, slope, form. Good. We'll practice and we'll graph and we'll do a lot of things here. So now I would like to show the 4 types of lines that we may encounter. These are the only types of lines. So types of lines. Okay. What type of line is this? What is the slope of a horizontal line? Perfect. What type of line is this? Yes, it's a vertical line, so this is undefined. What kind of slope does this have? Very good. This is a positive slope. If a line goes from negative values to positive values, it has a positive slope. If a line goes from positive values to negative values, it has a negative slope. Okay, lines. 2 lines can be parallel or perpendicular or none of the above. So lines can be parallel, perpendicular, or none of the above. So if 2 lines are parallel, let's say the first line has slope m1 and the second one has slope m2. What has to happen? If they must be? Very good. If 2 lines are parallel, they must have the same slope. Let's take a look at 2 perpendicular lines. Let's say this is one line. And let's say this is the second one. Perpendicular means they form 4 90-degree angles. Very good. And let's say this is M1. And let's say this is M2. What would be the relationship between M1 and M2 if they are exactly perpendicular? Not opposites, but negative inverse, negative multiplicative inverse, yes. M1 will equal the opposite of 1 over M2. I really don't remember it like this myself. It's up to you. I just cross multiply. M1 times M2 equals -1. This is what I like to remember, but they are the same. Right? Put M1 over 1. M1 times M2 equals -1. This is how I like to remember it, but it's the same thing with the first one. Okay, so now I just wanted to let you know that Saturday, it's, is it a 27, 20, 29, right? From 9 to 10 a.m. I will be at Arundel Mills campus. If you come, then you can go to the casino. No, I'm not saying that. When did it open? 5, 6, 7 years ago? 5 years? I set foot one time in it because a friend of mine wanted to see it. So I know nothing about it. So at Arundel Mills campus in room 401, I have a review with everyone from your class. I teach other sections of this class. So if you're interested, I will have a review for the test. Okay?
When's the test?
Next week or the following Tuesday. Okay?
And that's for all the material up to.
Including 2.5. Yes. So we are not setting it up right now because I don't know how fast I can finish. So I still have, what is it? It's 2:10, right? So what do I have? I have 35 minutes left, so I don't know how much I can accomplish. I don't think I can finish. So, but I will finish hopefully Tuesday. So it's going to be the following Tuesday. But it's a It's a good, if you would like, if you're interested, you can come from 9 till 10, Saturday, Rundle Mills. Okay? So I may be able to do another review, we'll see. But I can't promise right now. Okay? Ready? So let's look at problems from 2.3 and 2.4. They are both review. So on page 267,